Hello and welcome to the fifth chapter of Radar Systems, Part 1. Myself Sanjit Kumar Singh, lecturer in Electronics and Telecommunication Department at Praveen Patil College of Diploma Engineering and Technology, Bhandar. So, in this chapter, the learning objectives are: number 1, the unit outcome is to explain with relevant sketch the working principle of the given type of radar. Number 2, describe the applications of the given type of radar. And number 3, describe with relevant sketch the working principle of the given type of display used with radar system. And fourth is to compare the continuous wave and the pulse radar for the given parameters. And the course outcome is to maintain various types of radar systems for specified applications. This unit is of 12 marks and 8 hours allocated lectures. The syllabus topics to be studied in this presentation and the upcoming fourth presentation will be: in part 1 we will see the Doppler effect and continuous wave Doppler radar with respect to block diagram operation application, and we will see the frequency modulated continuous wave and Doppler radar block diagram operation and application in the first part. In the second part we will see the MTI with the block diagram operation and concept of the blind speed and application, and automatic target detection radar and display methods. Among the display methods we will see the AScope and PPI in the second part, and third part will cover the beacons, that is a special type of transmitter receiver set of radar called racons, and sonar system will be covered in the third part. So first of all, let's see what is Doppler effect. The frequency shift that occurs when there is a relative motion or radial motion between the transmitting station or a source and a remote object or an observer. This effect was first proposed by the Austrian scientist CW Doppler in the year 1842 and therefore named after him Doppler effect. So such effect is experienced in day-to-day daily life as a honking car or a car is generating noise. As it is approaching, we see intense sound signal, and as the car is passing by, then observer one is experiencing or hearing signal of lower frequency, whereas the driver is hearing a constant frequency at the source of generation of the sound. So a target moving, if it is moving across the field of the view of a radar, then there is no Doppler effect, no frequency shift observed, and therefore cannot be detected. So applications, what are the applications of Doppler effect? There are many applications of Doppler effect. It is used in astronomy for studying the different movement of the stars and planets, whether it is approaching each other or receding away from each other. Then in radar, then it is used and studied in medical imaging and blood flow measurement. For example, the echocardiograms, and for ultrasonography it is made use in medical field, and for police radar gun also makes use of the Doppler effect. So there are many applications of the Doppler effect in day-to-day daily life. Continuous wave Doppler radar. Continuous wave Doppler radar, the simple block diagram is shown in the adjacent figure. So what we see in the block diagram is that the continuous wave radar, which makes extensive use of the Doppler effect for target speed measurement, is drawn. So continuous wave radar makes or produces the continuous sine wave, for example, at a frequency ft, and is transmitted through the transmitting antenna after it has passed through the circulator. So circulator keeps the continuous signal coupled to the transmitting antenna, and the received echo signal with the frequency drift of frequency change depending upon the distance it has traveled to the target is obtained by the receiver set. So since the circulator is providing an isolation of 30 dB, it is not a complete isolation between transmitter circuit and the receiver circuit. So some of the signal, transmitted signal, is leaking into the receiver part, receiver circuit, and therefore it mixes with the received signal from the receiving antenna and is fed to the detector, where the detector is a diode mixture which mixes this leaked transmitted signal with the received signal from the receiving antenna, FT plus minus FD. So the output of the diode detector is nothing but a Doppler frequency shifted signal, and it is in the range of audio frequency. Therefore we require the audio amplifier which amplifies before the signal is fed to the frequency counter. Now the frequency counter is a normal frequency counter which has an indicator or output which calibrated in terms of kilometer or miles per hour, kilometer per hour or miles per hour. So that is the simple continuous wave Doppler radar and block diagram and the working we saw. A slight modification can be done with the help of the IF amplification that we will see after this. Advantage, disadvantage and applications of continuous wave Doppler radar. Advantage, what are the advantages of continuous wave Doppler radar? So accurate measurement of relative velocities can be achieved using continuous wave Doppler radar. Then the continuous wave Doppler radar makes use of low transmitting powers, and it has simple circuitry with low power consumption and is smaller in size and remains unaffected by the presence of stationary targets. It can detect a large number of stationary targets, but it may get confused, so that comes under the drawback. And the range that it can measure the relative velocities or velocity speed measuring can be done up to down to 0 range. Disadvantage, the major disadvantages include the lack of sensitivity. Then as the diode detector is used, that is not considered as a good receiving technique or demodulation technique, as there could be modulation noise showing up at low frequencies. Transmitter power is limited, or it is limiting the transmitted power emitted from the transmitter set is limiting the maximum range that the signal can travel and come back. So, and as stated earlier, it may get confused with the presence of the large number of targets. And moreover, very important is the continuous wave Doppler radars are incapable of indicating range. So that is a very big problem for the Doppler radar. Continuous wave Doppler radar are incapable of indicating that target range. What are the applications? Some of the applications, it is used in aircraft navigation for speed measurement, in rate of climb meter for vertical takeoff planes, in radar speed meters used by police. So these are the major application areas of continuous wave Doppler radar. Here is a modification of the simple continuous wave Doppler radar with IF amplification. So in this arrangement, a small portion of the transmitter output is mixed with the output at a local oscillator, and the sum signal is fed to the receiver mixture. So that is FT plus FI signal is fed to the receiver mixture, and this mixture also receives the signal from the Doppler shifted signal from its antenna and produces an output difference frequency difference frequency, that is typically near about 30 megahertz plus minus the Doppler frequency. The output of the mixture is amplified and demodulated again, and the signal from the second detector is just the Doppler frequency. Moreover, its sign is lost. So that it is not possible to tell whether the target is approaching or receding, going away. And moreover, extra sensitivity is provided by the lowered noise, because of the output of the diode mixer is now in the vicinity of 30 megahertz, at which FM noise has disappeared, and the separate transmitting and receiving antenna provides increased isolation between the two. The continuous wave transmitted oscillator that can be used is for less than 100 watt, and hence the gun diode can be used, or continuous wave magnetron can be used. Now this second type, frequency modulated continuous wave radar. So earlier we have seen the unmodulated continuous wave Doppler radar. Here we have the frequency modulated continuous wave radar. So here we have separate transmitter and receiving antenna, so that it provides additional isolation between the transmitting and receiving received signal. The sawtooth generator can be used, or any other waveform like a triangular or a sine wave can be used as a source of a frequency modulation, and the signal is frequency modulated and then fed to the transmitting antenna. The transmitting antenna is transmitting with 1 to 2 watt of signal, and it is since it is a continuous wave radar, it will be transmitted continuously through the transmitting antenna. The receiving antenna receives the Doppler shifted or Doppler frequency of the transmitted signal after the reflection from the target or remote object, and is directed towards the mixture, where it has a reference input from the transmitted signal as well, and the output of the mixture could be sum and difference signal. So here the difference signal is processed and amplified by the amplifier, and then it is given to the amplitude limiter. Since in frequency modulation the noise generally increases or decreases or changes the amplitude of the signal, therefore this amplitude changes are limited or removed, controlled by amplitude limiter, and the output from the amplitude limiter is given to the frequency counter, which is again a normal frequency counter, which will be calibrated in terms of the miles per hour or kilometer per hour. So here the frequency shifted signal, the frequency shifted Doppler frequency signal is proportional to the height of the plane, that is between the earth and the plane, and if the rate of change of a frequency with a time due to the FM process is known, time difference can be readily calculated, and so can the height. The output of the mixture which produces the frequency difference can be amplified, fed to a frequency counter, and then to an indicator calibrated in meters or feet. So it will give the range. If the relative velocity of the radar and target is not 0, then another frequency difference or bit will superimpose itself on top of the frequency difference because of the Doppler frequency shift. However, the average frequency difference will be constant. Thus, correct height measurement can still be made on the basis of average frequency difference. So the greatest drawback of the Doppler radar is its inability to measure the range, and that is overcome in this FM frequency modulated continuous wave radar. What are the advantages and application of FM continuous wave radar? So the major application of FM CW frequency modulated continuous wave radar is in altimeter to measure the height of the planes, and it is preferred over the pulse radar because because of the short ranges for the height to be measured, as the continuous wave has no limit on minimum range. It can measure up to 0 range, and low power equipment can be used. Small antennas are used as size and proximity of the earth, and moreover the transmitted signal is of the C band, and it is in the range 1 to 2 watt. The transmitted signal is 1 to 2 watt that can be generated with the help of an impact or gun diode, and with this 1 to 2 watt signal, it is sufficient to cover a distance of a range of 10 kilometer or more with accuracy of 5%. So that's all for this presentation. In the next presentation, we'll see the MTI, moving target indication type, and the display methods of the radar. Thank you very much.